Hello 186 friends, welcome to chapter 6. We are going to start our trigonometric functions for section 6.1, angle measure, special triangles and special angles. Okay, so let's first start with talking about the parts of an angle. An angle is made up of two rays that start at what we call the vertex. They come out of the vertex and they go on forever. And the angle is the distance traveled from one ray to the next. So we usually identify angles with Greek letters. That just happens to be the Greek letter alpha. Notice here that I started here and I can tell that I end here, and this is the direction I'm going. So this angle travels upward, and that's indicated by that arrow right there. I could travel this way. We could talk about this angle, and I'll call that one beta, right? So if we are traveling upward or in a counterclockwise direction, that is called a positive angle. So if we rotate this way, heading to the left, we turn our faucet to the left, we call that counterclockwise. That would be a positive angle. If we're turning our faucet this way, or at the angles pointing down, that's a negative angle, and that's in the clockwise direction. So there are different units of measures for angles. Angles can be measured in either degrees or radians. So degrees, well, as we all know, if you make one trip, an entire trip around, we turn our faucet all the way around and the top of the faucet's right where it started, that would be 360 degrees. So 360 degrees is one complete rotation. So from that, we can deduce that a half of a rotation would be 180 degrees. A quarter of a rotation, a quarter of a rotation would be 90 degrees, so forth and so on. So I'm just going to fill in some more angles here. So if we don't rotate at all, we're at 0 degrees. We rotate it a quarter, we're at 90 degrees. We rotate it halfway around any object, or our angle is rotated halfway around, that's 180 degrees. We go another 90 degrees, it could be 270 degrees, and then we're back up here at 360 degrees. So notice 0 degrees, 360 degrees, and then if I go another 90, let me put this one up here too, 90 degrees, that would be 450 degrees. So if we rotate it all the way around and go another 90 degrees, that angle would be 450 degrees. This one would be 540 degrees, right? And we can just keep spinning that faucet over and over and over again. Keep in mind that 90 degrees does not equal 450 degrees. So imagine turning your faucet a quarter of a turn or turning it all the way around plus a quarter. Clearly the result is different. One, you'll have a higher water flow than the other. So the terminal side, or the end of the angle, is they land in the same spot, but one has a complete other rotation. All right. So angles that start in the same position but end in the same position, but are actually different angles, are called coterminal. So coterminal angles have the same initial side and the same terminal side, but not necessarily the same angle measurement. So for example, 90 degrees and 450 degrees are coterminal angles. Also, if we go back one, let's see, we can see that 540 and 180 are also coterminal angles. Just like other quantities, we can use different units to measure angles. When we think about distance, we can use feet, or we can use meters, we can use miles, we can use kilometers. We can measure angles. The two units of measurement are either degrees or radians. Degrees are more common, and it's what our brain typically thinks of, but radians is more commonly used in mathematics and applications. So let's talk about how do we identify a radian. Well, if we have a circle of radius 1, so that means the distance from the center to the outside is 1 all the way around, and then we literally take this distance of 1 and we travel 1 unit on the outside of the circle. So we're going to travel this far, but on the outside of the circle. So that looks like maybe about that. So if this is 1 unit, right, so if we take this angle and we go from here all the way up to here, right there, that angle that's produced by taking a circle of radius 1, traveling 1 unit on the outside of the circle, starting here and ending here, this would be 1 radian. So then if we go another 1 unit out here like this, and we go from here to here, suppose that's another 1 unit, this angle would be, from there to there, would be 2 radians. And RAD is how we abbreviate radians, plus I ran out of room. 3 radians would go another. 3 radians would be about right here. That would be another one. And then the angle, this size angle, would be 3 radians. Now notice that's almost halfway around, just short of halfway around. If we continued this process, 1 whole trip around would be a little more than 6 radians. In fact, if we think about it, it would just be the distance around this circle, because that's a length of 1 unit corresponds to 1 radian. And if we look at the distance around a circle of radius 1, the circumference, of a circle with radius 1 equals 2 pi. Therefore, 1 complete rotation is equivalent to 2 pi radians. Which is equal to 360 degrees. So 2 pi radians is equal to 360 degrees. So if 360 degrees is 2 pi radians, we don't use any symbol after radians. If I said an angle is 2 pi, we assume it's in radians. If you're using degrees, it is essential that you use the degree symbol, otherwise it's assumed to be radians. Right, well, halfway around the circle was 180 degrees, so halfway around 2 pi would be pi radians. So 180 degrees is pi. So if you know this guy, you can pretty much find you can find the equivalent radian measure for any degree. Well, 360, half of 360 is 180, so half of 2 pi is pi. Well, half of 180 is 90 degrees, so half of pi is pi over 2. So 90 degrees is equivalent to pi over 2. And half of 90 degrees is is half of pi over 2, so that's going to be pi over 4. 30 degrees, well, let's go back up to 90. 30 degrees is 1/3. So here, I'm going to go back to this right here, right? It's 1/2 of pi over 2. 45 degrees is 1/2 of pi over 2. That gives us pi over 4. 30 degrees is 1/2 of pi over 1/3 of pi over 2, because 1/3 of 90 degrees is 1/3 of pi over 2. So 30 degrees is pi over 6. 60 degrees is twice 30 degrees, so 2 pi over 6's. It's going to give me pi over 3. And 0 degrees is 0 radians. So notice none of the radians have a symbol on them. All the degrees have to have a symbol on them. So I am going to use, you want to be able to quickly identify the relationship between degrees and radians. So again, if you know 360, you can quickly identify 180, 90, 45, 30, 60, and 0. But you want to memorize these. Make flashcards. Do what you have to do, but be able to go back and forth between these two. Let's look at some more angles. We are often interested in angles that are multiples of 45 and 30. So 45 degrees, remember, is pi over 4. Right, so 90 degrees is 45 times 2, right? 45 times 2. So it's pi over 4 times 2. So 2 pi's over 4, or pi over 2. 135 degrees is 45 degrees times 3. So it's 3 pi over 4. Because it's 3 times 45 degrees, so it's 3 times pi over 4. We can't simplify it. 180 degrees is 4 times 45 degrees. So it's 4 times pi over 4, which is just pi. 225 is 45 degrees times 5. So 5 times pi over 4 is just 5 pi over 4. 270 degrees is, 45 times 6. So it's 6 times pi over 4, or 3 pi over 2. 315 degrees is 45 degrees times 7. So that's just 7 pi over 4s. And 360 degrees, we're back where we started. That's going to be 45 degrees times 8. And notice we get 45, we get 8 times pi over 4, which is we're right back at 2 pi. And we could keep continuing. I could do 45 times 9, which would be 415 degrees. 45 times 9, which would be 9 pi over 4, which we can't simplify, and we can go on forever. So once you know pi over 4, you should be able to identify all the angles and radian measures that are multiples of 45 degrees. So likewise with multiples of 30, which in turn gives you multiples of 60, because all multiples of 60 are multiples of 30. So 30 degrees is just pi over 6. 60 degrees is pi over 3, right? Because it's just 2 times 30 degrees. You can think of it that way. So 2 times pi over 6 is pi over 3. Now 90 degrees, well, we can write that as 3 times 30 degrees. Or 3 times pi over 6, which is pi over 2. So 90 is a multiple of both 45 and 30. In both cases, we get pi over 2 as our final result for 90 degrees. 120 degrees, well, you can either do 4 times 30 degrees, or you can do 2 times 60 degrees. I think that's easier. 2 times 60 degrees would be 2 pi over 3s. So 60 degrees is 2 pi over 3. 150 degrees, well, 150 is not a multiple of 60, but it is a multiple of 30. It's 5 times 30 degrees. So 150 degrees is 5 30 degrees is, or 5 pi over 6. 180 degrees, well, is both a multiple of 30 and 60. So I'm going to do 3 times 60, which is 3 times pi over 3, which is just pi. 180 degrees was also 4 times 45, which gave us pi. 210 degrees, not a multiple of 60, but it's a multiple of 30. It's 7 times 30. So it's 7 times pi over 6, or 7 pi over 6 is 210 degrees. 240, again, is a multiple of 60 and 30. I'm going to do 4 times 60, which is 4 times pi over 3, 4 pi over 3. Or it's 8 times 30, which would have been 8 pi over 6, which would have simplified to 4 pi over 3. 270 degrees is a multiple of 30. We're going to do 9 times 30. So 9 pi over 6, which is equal to 3 pi over 2. 300 degrees is 5 times 60, or it's 10 times 30. Either or, we're going to get 5 pi over 3. 330 degrees is not a multiple of 60, but it is a multiple of 30. It's 11 times 30 degrees, so it's 11 pi over 6s. 360 degrees, well, we're back at the origin. And 360 degrees is a multiple of both 30 and 60. You can choose either one. I'm going to do 6 times 60. So it's going to be 6 pi over 3, which is 2 pi. Or we could have done 12 times pi over 6, or 12 30 degrees, we still would get 2 pi. So you want to be able to, without looking at a table, be able to convert between degrees and radians and degrees. Okay, not all angles are going to be multiples of 45 degrees or 30 degrees, so we have to have some way to be able to convert from one to the other. All right, so if we have a degree measure and we want to find the equivalent radian measure, we multiply by pi over 180. So for example, 180 degrees, 180 times pi over 180 is going to give me pi radians. If I had 210 degrees, it's going to be 210 times pi over 180. And we're going to simplify that. 30 goes into both of these, so we can divide 210 and 180 by 30. We get 7 pi over 6 radians. I often just try to remember that 210 is a multiple of 30, and I know 30 is pi over 6. So 7 times 30 is 210, so 7 times pi over 6 is 7 pi over 6. However you do it, you have to be able to make these conversions. If we're given radians and we want to go back to degrees, we multiply by the reciprocal, 180 over pi. So for example, pi radians, well, it would be it'd be pi times 180 over pi. And a good way to remember, if you're not sure, to multiply by 180 over pi or pi over 180, many radian measures have pi in them, so you need the pi to cancel out, and it will give me 180 degrees. Don't forget the degree symbol. If you don't include the degree symbol, it will be incorrect. So let's do 5 pi over 4 radians. And we're going to get to the point where we're not going to write radians anymore. If it doesn't have the degree symbol, we're just going to assume it's radians. So we're going to do 5 pi over 4 times 180 over pi. And then we say to ourselves, well, 4 and 180, we get 90 over 2, so that's 45. That goes in 45 times, so this is 5 times 45 all over 1, which is 225 degrees. So you want to be really good at going back and forth, and the only way to do this is to practice. So just a couple more. Let's suppose I had 270 degrees and I wanted to go to radians. It would be 270 times pi over 180. So I'd get 270 over 180. That would be 3 pi over 2 simplified. It's helpful to use the fraction feature on your graphing calculator too. So if you go into your graphing calculator and don't ignore the pi, let's just do the 270 on top divided by 180 on the bottom. Whoops, make sure you're cleared. 270 divided by 180, we get 1.5. We don't say 1.5 pi though. We're going to convert it to a fraction. We go math, enter, enter, and that's going to be our 3 pi over 2. Let's suppose I had 100 degrees. 100 degrees. Well, 100 times pi over 180, okay, let me just put this in for now, and again, eventually I won't do this, is going to be, well, it's going to be something pi. What's 100 divided by 180? Well, it's that. We'll never use that number, but if we go math, enter, enter, it'll simplify the fraction for us. It's 5 pi over 9 radians. 2 pi over 5 radians is equal to 2 pi over 5 times 180 over pi. The pi's cancel. And I'm going to do 2 times 180 divided by 5. 2 times 180 divided by 5. It's going to be 72 degrees. Right, when we first introduced the concept of radians, we called 1 radian the measure of moving 1 unit outside the circle. So 1 radian is about equal to, if we go back to this picture, it is, I don't know, what does that look like? Almost about 45 degrees-ish, right? So how many degrees is that? Well, 1 radian is 1 times 180 over pi. Now notice there 1 radian doesn't have a pi in it, so it's just going to be 180 over pi degrees. Whoops. And that's about equal to, if we do 180 divided by pi, it's not a nice number. So just follow the directions if it's looking for an exact number or not. It's about 57.3 degrees. So 1 radian is a little more than 45 degrees, not quite 60 degrees. All right, drawing angles in standard position. When we study trigonometry, we often put our angles in standard position in the XY plane. We always put the vertex of the angle at the origin. So vertex at the origin. The initial side always corresponds with the positive x-axis. And then we rotate from here. If it's a positive angle, we're going to rotate up. If it's a negative angle, we're going to rotate down. So the angles between 0 and 90, its terminal side will fall in the first quadrant. If it's between 0 and 80, it'll fall in the second, so forth and so on. So we'll just, in general, right here, let's just suppose this is my angle. I'll call it theta this time. The terminal side will fall in one of the four quadrants or on one of the axes. So we want to get in the habit of drawing our angles in standard position. So, oops, my kitty's saying hello. What's up, Lil? You just ate. I'll get back to you in a minute. Okay, shh. All right, let's draw 315 degrees in standard position. Keeping in mind, all right, so degrees, so we have 90 degrees is here. This is 0 degrees. This is 180 degrees. We have 270 degrees down here, and then we're back at 360 up here. So 315 must fall in the fourth quadrant. So if we go 180, 270, well, 315 minus 270, we have to go 45 degrees more. And one quadrant is a 90-degree angle, so 45 degrees cuts my angle in half. So here's my initial side. Here's my terminal side. It's going to go right through right here. And then we usually indicate, because we have two angles here, we have this angle, and that's our angle of interest. It's a positive angle, so we're going to move in the counterclockwise direction. So this would be my angle, 315 degrees. But note, this angle right here, if we started here and ended here, but turned clockwise, our terminal sides would be the same, but the angle would be different. This would be negative 45 degrees, because we started here and we went down 45 degrees. So 315 degrees and negative 45 degrees are coterminal angles. That is, their terminal side coincides when drawn in standard position. But, so 315 degrees is not equal to negative 45 degrees. They're not equal angles. They land in the same position. So again, imagine turning your faucet 315 degrees, or if you turn it negative 45 degrees, you're going to get a very different result, although the faucet would look the same in the end position. Right, other angles coterminal with 315 degrees. Well, what about if we go around? So you know what, I'm going to keep going. I'm going to turn my faucet one more time around. That angle. So it would be 315 degrees, but then we go another 360. So 315 plus 360 would be 675 degrees. Right? And then what if I did this again? It'd make my picture way too messy. What if I went around once, I stopped at 350, and then I did another 360, and then I did another 360. Well, if we add 360 to 675, we're at 1,035 degrees. And I could keep going on and on and on. So there's infinitely many angles coterminal with 315 degrees. We could also go in the negative direction. I could go negative 45 degrees, but I could also go another negative 360. So if I went another negative 360, I would be at negative 405 degrees. So that would be a rotation of negative 45 plus an additional one time around. Right? And we could continue this forever. So we're going to now introduce the notation for all angles coterminal with 315 degrees. So all angles coterminal with 315 degrees is going to be 315 degrees plus 360, 360 degrees. So that would give us that 675. And then if I added another 360, we're really adding 720. And I can keep adding multiples of 360. So how we indicate that is we use this K. So we say 315 degrees plus we keep adding multiples of 316 degrees, where K is any integer. Remember, your integers are your counting numbers, 0, 1, 2, 3, forever, and their negative counterparts. Right? So any multiple, positive or negative multiple of 360, when you add it to 315, so this is how we say 315 degrees and all angles coterminal with 315 degrees. Right, if we were in Radian Measure, well, if we start a problem in Radian Measure, if Alex introduces a problem in Radian Measure, they're going to want the answer in Radian Measure. So 315 degrees would be 7 pi over 4, because it's 7 times 45 degrees. If we look back at the picture, too, another way is you can count. So this would be 1. If we divided this up into 45 degrees, I know that's really horrible, but so if I divide my quadrants in half and look at my axes, would be 1 pi over 4, 2 pi over 4, 3 pi over 4s, 4 pi over 4, which would be pi, 5 pi over 4, 6 pi over 4, this would be 7 pi over 4. So 315 degrees is equivalent to 7 times 45, or 7 pi over 4s. And instead of adding 360, well, remember 360 degrees is equivalent to 2 pi. Okay. Right. In general, so that's for 315 degrees. In general, for any angle, to write all angles coterminal with that angle in degrees, we would put the angle plus all multiples of 360. So it'd be theta plus 360 degrees. If we were using radians as our measure, we would do the angle plus all multiples of 2 pi. So here's a little exercise. It says list 3 positive angles and 3 negative angles coterminal with pi over 6. So I'm going to take pi over 6, and I'm going to add, we're going to use this because it's radian measure, and I'm going to add 2 pi, because that would be pi over 6 plus 1 additional rotation. So now we're just going to add these. We're going to turn them into common denominators. It's going to be pi over 6 plus 2 pi is equivalent to 12 pi over 6. So 13 pi over 6 would be one angle. If I add another multiple of 2 pi, so I'm going with my positive angles first, I'm going to say pi over 6 plus 2 pi. I'm going to add a multiple of 2 pi, so it would be 4 pi. So it would be pi over 6 plus 24 pi over 6, which would be 25 pi over 6. I can add any multiple of 2 pi. So I can do 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. I'm going to do 10 pi. Any multiple of 10 pi. Any multiple of 2 pi, and 10 pi is a multiple of 2 pi. So pi over 6 plus 60 pi's over 6, it's going to give me 61 pi over 6. The negative angles, we're going to subtract multiples of 2 pi. So pi over 6 minus 2 pi, which would be pi over 6 minus 12 pi over 6, which would be negative 11 pi's over 6. So if we were to draw pi over 6 and negative 11 pi over 6, they'd look exactly the same at their initial and terminal side. There'd just be an extra rotation with that guy. So pi over 6 minus, I don't know, let's do 6 pi, because that's a multiple of 2 pi. So pi over 6 minus 36 pi over 6. So negative 35 pi. Oops, don't forget the 5. Pi over 6. Right, you can do any multiple of pi over 6. So I'm going to do 100 pi's. Sorry, again, any multiple of pi over 2. I keep looking above. So this is going to be pi over 6 minus 600 pi over 6, which is going to be negative 599 pi over 6's. Right, so as long as you add or subtract any multiple of 2 pi to an angle, you'll get an angle that's coterminal. All right, let's try a little problem. Let's find an angle between 0 and 360 degrees that's coterminal with 1,000 degrees. So one of the easiest ways to do this for this angle would be to draw 1,000 degrees. So if we start here, we go around once, we're at 360. So we start at 0, and then we're at 360. All right, so I'm going to go around again, and if I go around again, if you notice I'm at 720. If I go around again, I'm going to be at, add 360 to this, I'm going to be at 1080. So 1080 is too much. So I only want to go to 1,000. So I'm going to be 80 degrees short of another trip around. Keeping in mind, one quadrant is 90 degrees. So if I went all the way around again, I'd be at 1080, but that's too big. So I have to go 80 degrees less. So it's going to be about right here. Here, and this angle in here is 80 degrees. So this angle out here is 1,000 degrees. Well, that's actually negative 80 if we go that way, right? So I'm going to cross that off. There we go. If we go that way, we're at negative 80 degrees. But the angle we're looking for is between 0 and 360. So what we want to know is what would this angle be right out here? Well, it's 80 degrees short of one trip around. One trip around is 360 degrees, right? So if we take 80 away from 360 degrees, so 360 degrees, we're 80 degrees short of one complete rotation, so it'd be 280 degrees. So if we turned our faucet 280 degrees, or if we turned our faucet 1,000 degrees, it would look exactly the same as we looked down on it, although the water flow would be quite different. All right, so I just keep counting around until I know if I go too far, I have to find an angle between one trip around and 2 trips around and 3 trips around, and we can just sort of deduce it logically. All right, let's try this with 2,000 degrees. I think 2,000 degrees. Well, one trip around is 360, so we start at 0. One trip around is 360. 2 trips around is 720, right? So we're at 720. 3 trips around was 1080. There's got to be a better way, right? So 3 trips around would be 1080 plus another 360. So another 360 would be 1440, right? I'm just going to make sure that I don't mess this up. Right, 1440. Right, so another trip around would be at 1440. Right, so that's 1 trip, 2 trip, 3 trips, 4 trips around. If I go another trip around, am I at 2,000 yet? No, 1,800. Okay. Well, if I go another trip around, I'm at 1,800 degrees. And we can see to get from 1,800 to 2,000, we just need, at this point, we need 200 degrees more. All right, so we're just going to go 180 degrees would be right here, and then 20 more degrees. This is where 2,000 degrees would fall. This angle from here to here would be 200 degrees. So the answer is 200 degrees. All right, notice a way to do this algebraically, you can ask yourself, how many times does 360 go into 2,000? So if you take 2,000, you divide it by 360, it says you can take 5 laps around with a little extra. So what I would do is I would take my 360, I would do my 5 laps around, that tells me I'm at 1,800. And then that little extra is how much more I would have to go to get to the 2,000. So if you did 2,000, divided it by 360, make sure you pop it in, right? We get this. We're going to subtract the whole part of the number. So we're going to subtract the 5 trips around, and then we're going to multiply that by 360, and that gives us our 200 because we're going a little more than a half of a trip around. All right, so that being said, can we find an angle between 0 and 360 that's coterminal with 3,000 degrees? Well, I'm sorry, 3 million degrees. Certainly we're not going to sit here and want to go around a whole bunch of times. Right? So if we do 3 million divided by 360 degrees, it's going to tell us how many rotations we can fit in there. So 3 million divided by 360 is 8,333 plus a little bit more. So 8,333 plus rotations. So this is what we need to know. How much more do we have to go? Well, 8,333 rotations times 360 degrees. So let's take that. 8,333 times 360. That's only going to bring us to 2,999,880 degrees. So how much more do we have to go to get to our 3 million? If we take our 3 million and we subtract, whoops, ignore that, 2,999,880 degrees, we get 120 degrees. So if we go down, because we go around, right, 3 million times, it's going to be equivalent to landing on 120 degrees. So this is 3 million degrees, would have to go around 8,333 times, but would land in the same exact spot as 120 degrees. All right, so that's part 1. Stay tuned for part 2. See you in a few minutes.